This question is asking us to find the horizontal asymptote of g of x. And they give us this function. It's a really long function. It might seem a little confusing, but remember, whenever we're looking for horizontal asymptotes, we'd really, again, just care about our leading terms. So we can say, well, g of x, it says it equals this, but whenever we go all the way to the end on either side, we want to think, oh, well, what's it gonna kind of look like there? We only care about the leading terms. And so in the numerator, I see that the leading term, the one with the biggest exponent, is 2x cubed. And in the denominator, the term with the biggest exponent is 8x cubed. But we're not done here. After we find our leading terms, we then have to reduce this fraction. I see that there's an x cubed on the numerator and the denominator, so I know that those x cubes will cancel out, and all I will be left with is 2 over 8. You could stop here, but you're all great mathematicians, and so we're going to reduce our fractions. And so 2 over 8, I know that both of those can be divided by 2, divide by 2, divide by 2. And so we end up with our horizontal asymptote at 1 over 4. So that means our final answer, we would want to see something where we say g of x has a horizontal asymptote, at y equals 1 over 4. What this is telling us is that we are going to have a function that looks like this. And I don't know what's happening in the middle here, really. I can't tell you just from looking at this graph, or from this function. But what I can tell you is that when x gets really big, when x gets really big in the negative direction or in the positive direction, the function will get closer and closer to y equals 1 over 4, this value. Y equals 1 over 4. And so we could think, oh, the function might look something like this. I don't know. I'm just going to draw random things. You see how it's getting really close, but never touching this line.